I believe there is a chat feature on there. This is the first time we've used this this web tool, the GoToMeeting, and so we're not quite used to how it all works. But if you do have a question, and we've received a couple of questions, if you do have a question and want to email it to us, if you send it to randy@cnkengineering.com, I'll show you at the end the slide for that. Okay, so let's get started. This is the copyright blather that we put up there about reproduction and distribution without permission of C&K Engineering. So that's just our copyright notice. So here's the topics we're going to cover tonight. Somebody has their mic on hot. If you would mute your mic unless you want to make a comment, that would be helpful. So we get a lot of background noise. So we're going to generically use the term wireless microphones to include several different products. Wireless microphones, wireless in-ear monitors, wireless musical instrument links, wireless production communications headsets, and wireless hearing assist systems. And so we'll just use the term wireless microphones to refer to any of those. So here's the topics we're going to cover today. We're going to talk about the FCC spectrum reduction and what has happened in the last few years and what's going to happen going forward, and what you as end users must do to effectively use wireless microphones. We're going to talk about two different parts of the way you can operate wireless microphones, and one of them is Part 74, which is licensed operation, just like a small radio station where you have license protection. And the way most people have operated wireless microphones, and that's under Part 15 of the FCC regulations, which will continue, but has some inherent problems that might make it more difficult to effectively operate in the reduced spectrum that's available to operate. We'll talk about where you can operate, what frequencies, what channels you can operate your wireless microphones on moving forward. And we'll discuss the consequences of illegal operation. We have an example of a church that got a hefty fine for illegal operation. And talk about some of the common problems that people have with their wireless microphones, and some tips on how to fix them, regardless of where you're operating, and how to plan for future operation of your wireless microphones. So those are the topics we'll cover today. So here's what's happened to UHF wireless microphones. The UHF wireless microphones are the ones that most people have. They operate in between TV channels, in the white spaces in between TV channels. And if you see there on the green bar up on the top, this was the situation before June of 2010. You could operate between 470 megahertz, which was channel 14, all the way up to 806 megahertz. And that was channel 68 in the UHF band. And there was lots of space in between there because there weren't that many TV stations. Well, what happened was that in June of 2010, the 700 megahertz band, everything below from 698 up to 806 megahertz, was basically repurposed for wireless broadband use, and that's your T-Mobile and Verizon and people like that, and that's the 4G LTE that you use to stream video and send text messages and everything like that on your phone. And so that spectrum was taken away, and 700 megahertz, which was actually the best place to operate wireless mics, that went away and was repurposed. And so everybody should have gotten rid of their equipment and operated in the 500 and 600 megahertz band. Well, they did it again, and they repurposed the 600 megahertz band, and that's the red box at the bottom. And so they're in the process of transitioning now, where the only usable spectrum is 470 megahertz to 614 megahertz. And that transition period depends on which city you're in, when they will shut off your ability to use the 600 megahertz band. Sorry. And you can see I have a couple of examples up here where we showed some wireless microphones. There was plenty of space in between the TV station and this. This is some sort of public service band signal, because fire department, police department, people like that also use the same band for their equipment. So after June 2010, everything was crammed in between the 500 megahertz and the 600 megahertz band. You can see everything squeezed a little bit closer together. And after May 2017, that's the transition that's going on right now. As you can see, they're all TV stations, wireless microphones, in-ear monitors, everything has to fit in this band right here. And so there's a lot less space to operate your wireless microphones. So there's going to be a lot more equipment operating in a greatly reduced bandwidth, which is going to make it harder to find a clear channel to operate on. This discusses the difference between unlicensed and licensed operation. The great majority of people, unless you were a TV broadcaster, a film production studio, someone like that, ran unlicensed. You went and you bought your wireless microphone, you brought it home, you set it up, and you ran it. And in most cases, you hit an automatic channel seat button on the thing, and it just went and found a white space in between a TV station, and it worked, and you were happy. And that's called Part 15 operation. That's a set of regulations the FCC has. And down there at the bottom, you can see that you'll find a sticker somewhere on your equipment that says this device complies with Part 15 of the FCC rules. And the two main things is that you cannot cause harmful interference to any other device, and you must accept whatever interference your device receives from other equipment, even if it causes undesired operation. The other thing about Part 15 operation, you are limited to 50 milliwatts of transmit power. And the licensed operation, which was previously only available to broadcasters and production companies, is now generally available to lots of users. So you can protect and register your frequencies, and other people are not allowed to use those frequencies. You're just like a radio station with a call sign. You still can't interfere with other devices. That's never allowed. But you can require other devices that interfere with you. For example, the school across the street that tries to use the same channel, they can be compelled to cease operation on the channel that you have licensed. And another benefit is you can transmit up to 250 milliwatts of power, and you're allowed to use antennas that have gain. In unlicensed operation, again, you're limited to 50 milliwatts of transmit power, and you have to use the fixed antenna that comes on the equipment, and you're not permitted to add any extra antenna that has gain or any higher performance. So there are a lot of benefits to operating in the licensed Part 74 operating system. You will find on your equipment somewhere a label that has this FCC ID on it, and this number, this FCC registration number, this says that you have a legitimate FCC-approved, cleared and piece of equipment. This is whether you operate licensed or unlicensed. But you can see this particular Sony system. This is the operating range 566, 125 through 589, 875 megahertz. That's TV channels 30 through 33. It operates in that band. And you can operate anywhere there's not a TV station in that band with this piece of equipment. So, moving forward, where can you operate wireless microphones now? This chart shows a whole bunch of frequencies, and you'll see the UHF band is right here. And you can operate right now during this transition period. You can keep your 600 megahertz equipment for now, but you're going to have to transition out of it. We'll talk more about that in a little bit. But there's a whole lot more areas that you can operate equipment licensed and than you can unlicensed. This shows everything that's available to operate wireless microphones. There are a lot of reasons you wouldn't want to operate down in this extremely low frequencies because the antennas are huge down there. But some people use these for communications headsets, and they're actually Shure, who stopped manufacturing VHF microphones, is bringing them back onto the market just because they're trying to free up more channels where you can operate microphones. But you'll notice that this is licensed operation. for these VHF frequencies. You've got the ISM bands, and the 902 to 928, there's equipment available there, but you're sharing that with cordless telephones and a lot of other equipment, garage door openers. And then the 2.4 gigahertz and 5 gigahertz, those are the microphones that operate in the same band that your Wi-Fi equipment operates in. And some people find that to be a good solution, but you have to be careful and plan how you use that, because Wi-Fi is a time-shared operation. And so things stop and go and wait their turn, and you can start to get some dropouts because somebody's, if you're in a room with a whole bunch of people that are using the Wi-Fi, then your microphone is mixed in with all of theirs and it waits its turn to operate. So there can be problems with using the 2.4 gigahertz if you're not careful. So if you decide that you want to be a scofflaw and keep using the equipment that is not legal to use the 700 and 600 megahertz band, nobody should have 700 megahertz bands. Now, you got to realize that the wireless broadband companies pay billions of dollars to the federal government to have exclusive use of the 600 and 700 megahertz band. And the second bullet here says they have big legal departments and they know how to use them. Pay attention to that, because they will, and they will make intentional examples of people because they generate their revenue using that broadband frequency. And so they do not appreciate you using your wireless microphones in those frequencies. And wireless towers have equipment on them that monitors all the activity that's in a particular cell. And so if there's a cell phone tower nearby your venue, your church, your school, your club, they will be aware. And then they will file a complaint with the FCC, and you will get a cease and desist letter. And if you don't cease and desist, yeah, like Big Brother, I see a comment came out there. If the FCC is not, they're not driving around with a van looking for violations. What they do is they wait for a complaint to come in, and then they act on it. And I have an example on there. The FCC regulation 47 CFR, they can impose fines and forfeitures, and they can come in and confiscate equipment if people are really blatant about their violations. Most of the FCC enforcements have to do with, lately have been with pirate radio stations. We've got a slide coming on down a little farther about that. They can confiscate equipment. All of the reputable manufacturers of wireless microphones, such as Shure, Sennheiser, Audio-Technica, Electrosonics, AKG, Sony, they don't allow their dealers to sell any equipment that operates in the 700 and 600 megahertz band. If you go to their websites, you're going to see big notices on there. And if you go to any dealer that's an authorized dealer, they will not sell you any of this equipment. They sell that in other countries now. You got to be careful. A lot of this stuff shows up on eBay, and it's really priced well. But if you're not attentive to that, you can end up with some equipment that you can't use. One of the things that in a conference that I participated with Shure, they were quick to emphasize that if you have a piece of equipment that spans the illegal and the legal band, you still have to get rid of it. You can't possess equipment that's capable of operating in the 600 megahertz band, even if it tunes down into the 500 megahertz band. Now, if you did that and you never operated it back in the 600 megahertz band and no one complained, you could probably get away with it just fine. Like I said, there's nobody going to come knocking on the door looking for your equipment. But technically, you're not supposed to have 600 megahertz band equipment operating. Here's an example. This was a church over in California. They were fined $25,000. And what they did was they wanted to share their services with the whole neighborhood over in Panorama City, California. And they set up an unlicensed radio station on 95.1 megahertz right in the middle of the FM band, which you can legally do as long as you're below a certain transmit power. A lot of people use the regular FM broadcast band for their hearing assist systems. There's a church over in Scottsdale that you pull into the parking lot, and they have a big glass wall, and you tune your car radio, and you can be in the service that's inside while you sit out in the parking lot and watch it through the glass wall. This is the same method that drive-in movie theaters used to use when they got rid of the speakers that you hung on the window, for those of you that remember driving movies. So anyway, this church was fined $25,000 back in 2015. So the FCC will enforce their regulations. This is a map that shows how many enforcement actions by state the FCC has had between 2003 and 2017. I'll enlarge this a little bit. You can see Arizona, they had 11 enforcement actions. Now this, I got the slide from the FCC's website. It doesn't say what the action was. In some cases, you just send a letter and the people stop. New York City area and Miami seem to be the hotbeds of illegal operation. Looks like there's a lot of stuff over on the West Coast in California. But they do enforce their regulations, and you don't want to be on the receiving end of the wrath of the government. So here's some common problems that people already have with wireless microphones. And I'll show you some pictures a little bit later on that show why some of these problems exist. If you open up the box that your wireless microphone came in and look at the owner's manual, it will say something to the effect, usually they say that they'll operate for around 300 feet. And then there's a little asterisk that says, under ideal conditions. Well, ideal conditions usually aren't a theater or a church or a club, because you have a lot of people in the audience, you have costumes, you have liturgical vestments, you have furniture, you have all kinds of things that block and interfere with reception of radio signals. The 300 feet means in clear air, and so you're going to have some reduced amount of that. And one of the problems people have is the antennas on the receiver don't have a clear view of the transmitter. There should be a line of sight between the transmitter, either the handheld microphone or the lav pack, and the receiver antenna. And anything that's in the way is going to either scatter the signal, or it's going to block the signal, or it's going to absorb the signal. And I'm going to skip forward a little bit and show you how this kind of thing happens. Here's a picture of a bad way to install wireless receivers. It's a nice, clean-looking rack. I blurred out the name on the power supplies up there, so you can't see. This is fine quality equipment, but you'll notice that the antennas are all packed down here behind the receivers, and they have a nice cooling grill in the front and then this power strip. So there's a bunch of metal in between the antennas and the front of the rack, and this was in the back of the sound booth behind the console, and the operator was sitting in front of it, and so the receivers were behind him so that he could see the controls on the receivers. But there was metal and the operator and the entire congregation in this church in between the receiver and the person that was talking. So the solution is you got to have a clear view of between the receiver and the transmitter. There's several ways that you can do this. One of them is to not mount the receivers in the rack, and you can put them up on a shelf where they're up high, so that the antennas are looking straight at the stage or the altar or the podium or wherever it is your person is presenting from. That's one of the important things, is that the clearer the line of sight is between the receiver and the transmitter, the farther the range of your signal that's going to operate. And the second one, the sound is distorted on the wireless microphone. If you have a reasonably good quality microphone, you have a gain setting on it. And that gain setting is the same as that gain knob that's on the input of your mixing console. And if you turn up the input setting on a corded microphone, and you turn that up too high, you're going to see that peak overload LED come on your console. Well, what happens is that peak overload would come on the console, except you're doing it to the transmitter instead of to your console. And then you adjust down the gain on your console so the peak light doesn't come on. Well, it's distorting back at the microphone. So you need to adjust the mic gain on your transmit just like you would on your console so that it's not distorting. Which brings to the second part, where the noise, along with the sound, there's noise with the sound on the wireless microphone. That's where the gain setting is set too low on the microphone, just as if you turn the input gain control on your console down and then turn the output fader up really high, you get a lot of hiss with it. It's the same thing. So you've got to visualize that your wireless microphone is the same as a corded microphone, except there's no cord in between it. And there's no input amplifier on the console because you have to adjust the gain at the wireless microphone. And drop me an email with your particular microphone if you're having a problem like that. A lot of people are using in-ear monitors now. They're very, very popular. That little slide we had at the beginning showed that what happened on New Year's Eve with Mariah Carey, the in-ear monitor stopped working and she ended up walking off stage. It was a big faux pas that ruined the whole show in Times Square on New Year's Eve. One of the problems is when you have in-ear monitors and a video wall behind the person that's using the in-ear monitors. And videos produce a lot of noise on their own that unfortunately is in the same band as the frequency that you're trying to receive with your in-ear monitors. And I have a slide. Let me skip forward to that right here. So this shows the yellow track. What we did was we took just a single 40-inch Vizio video monitor, and we turned off the monitor, and you can see that yellow track and all of those yellow spikes that you see up there, those are TV stations. So we had an antenna that was set up pointed towards the monitor. Then when we turn the monitor on, you can see the orange trace on there and the noise floor. For example, in here, and all in between here, you can see where the noise floor went up, in this case about 5 dB. That's from one monitor. Some of the video walls are built out of 60 or more monitors. So each one of those monitors that comes on this noise floor is going to go up higher and higher and higher. And if you're trying to operate your wireless microphone and your signal is only this high down here, pretty soon that noise floor is going to overwhelm, your in-ear monitor, the noise floor is going to overwhelm it. And that's where you start getting dropouts. And people start to, they'll turn just a little bit or walk around on stage and their in-ear monitor drops out. I've seen a lot of shows that this has happened to. And so you have to, back to here, you have to get as close to the possible your transmit antenna and your in-ear monitor. There's a lot of aesthetic reasons people don't want to put the in-ear monitor transmit antenna in front of the video wall, because sometimes the video wall goes all the way from the floor up to the top of the proscenium on the stage. But there are antennas that actually have a pretty low profile, and in some cases, if you have a wooden stage, people are actually putting the transmit antenna in front of the video wall and under the stage so that it shortens the distance between the transmitter and the receiver. Another key point is to never route your wireless in-ear monitor antenna cables near any video cables, especially if you're using HDMI, which is very popular. HDMI cables are notorious for having poor shielding, and the HDMI frequency is also right square in the middle of the UHF band on a couple of the bands. And so you should never route your video cables in any proximity to your audio cables or your antenna cables on your in-ear monitor equipment. The best thing you can do is to do a site survey where you walk around with an antenna, a piece of equipment called a spectrum analyzer, to find the best antenna placement for your in-ear monitor transmit antenna. There's a couple of questions that came up. The wireless microphones work okay when the building is empty, but not so well when the room is full of people. People absorb radio waves, and it's the same thing. If the antennas on the receiver don't have a clear view of the transmitter, you're going to lose signal. And we had one church we worked with. The antennas on the receiver were sitting right on the console, and the console was in the back of the room, and the wireless worked great, and then the congregation stood up to sing or for whatever part of the service that it was, and then the wireless microphone began working terribly because you had several hundred people that now blocked the view of the antennas with each other. So you got to get those antennas up high and over the heads of everybody in the audience. Now here's an interesting problem. The wireless microphone worked great at the start of the performance. This was in a stage play. and it degraded. It says the service progressed. This is actually a stage play that this went on. And what it was they had the wireless microphone underneath the costume so it wouldn't show the transmitter. And the person, there was a musical, and there was a lot of singing and dancing and all that stuff, and the costumes got sweatier and sweatier. Water will absorb an RF signal, and so the antenna was touching the sweaty costume, and so the transmit power was being absorbed by the sweat on the performer's costume, and the signal just kept dropping down farther and farther. So we came up with an interesting solution, and you can do this. It's very inexpensive. If you have religious vestments, or if you're in a theatrical thing where you get costumes and you have this problem, what we do is we take a piece of heat shrink tubing and we slide it over the antenna like this, and then you shrink the ends so the antenna can flop around inside this piece of heat shrink tubing. So your antenna is usually about 1/8 of an inch in diameter, and you get a piece of 1/2-inch heat shrink tubing and shrink it down at the ends so that it sticks onto the antenna. The antenna flops around in there, and that forms a barrier so that the wet costumes or wet religious vestments from the sweat buildup won't touch the antenna, and that helps to keep the signal from dropping out on the transmitter. So that's a very handy thing that you can do to keep from losing signal because of moisture buildup. The wireless microphone sound comes out on the same channel on the mixing board as another wireless microphone. This is just a case of bad frequency planning. If you have one microphone, you don't have a problem with where you put it as long as it's in a clear channel. As soon as you add 2 or 3 microphones on there, you have to carefully plan your frequencies because multiple signals will combine and form a third channel. And if your third microphone is set to that third channel, you can mute that microphone, but the receiver will still see the signal from the other 2 microphones. If your manufacturer's owner's manual that comes with your microphone has a frequency planning tool in there, or you can go to Shure or Sennheiser or Audio-Technica's website, and they have a planning guide where you enter the frequencies that you think you want to operate at, and it will tell you which ones that you can safely operate at. Then you have to see that those aren't interfering with any television stations or any other users. So these are some problems that people have talked to us about with their wireless microphones. So there's, again, our example of bad antenna installation where it's crammed in the back of the racks. There's our example of the video monitor causing interference. And there's our solution for beating sweat on loft packs. So now comes the shameless sales part of this whole thing. C&K Engineering, we are a licensed FCC low-power auxiliary broadcaster. And that's our call sign, WQYR310. And we can license under Part 74 your microphones if you wish. And we can provide you with protected frequencies that other people cannot use to interfere with you. There's going to be less and less spectrum available for unlicensed operation. So if you want to assure that you can have a clear channel to operate on, we can help you with that. We can evaluate your existing equipment and setup and make sure that it's properly installed for the best operation. Where your antennas go, we have the measurement equipment and antennas that we can come in and set up and find the best operating locations for your wireless equipment. And it will help increase the range so you don't get dropouts. We can help you plan migrating out of the 600 megahertz band if you've got 600 megahertz equipment, and find the best operating frequencies for your area. We go by your GPS coordinates, and we compare that to the strength of all the TV signals that are in your area and find the best operating channels for you to operate at. We help you find the best equipment for your budget. When you decide it's time to replace, and if you're going to have to replace, we'll help you find the right equipment for your budget and for the performance that you want. I just found this out the other day. Right now, Shure, and I'm not endorsing them in any particular more than any other company, but right now they have a rebate program where if you buy new Shure equipment to replace your 600 megahertz equipment, they will give you a rebate anywhere from $50 to $500 per channel. So if you, and that's one receiver and one microphone. So if you've got one of those multi receivers that's got four receivers in one box with 4 microphones, that would count as 4 channels. And naturally, the more expensive equipment you buy from them is the higher the rebate. That $500 rebate is on their Axient system and their ULX digital system, and those cost $6,000-7,000 per channel. So that's pretty high-end stuff. And if you're buying the stuff that you go to the music store and buy down there, it's going to be the $50 rebate that you get. But and they don't care. It doesn't have to be Shure equipment. They'll accept anybody's operating equipment in exchange in this rebate thing. And that is running until April of next year. So it's active now. So if you think you want to get Shure equipment, between now and April would be the time to do that. So, and then the last part is we're absolutely happy to provide a quotation for our services with no obligation. We're not high-pressure salesmen. We're RF engineers, and we just want to help you get your equipment to work as best as it can, because wireless microphones are wonderful. You don't have any tangling wires or anything like that. And it gives, churches, once they caught onto this, it gave pastors and lectors mobility. They can move around. It's just wonderful. And theater loves it and everything like that. Shows, it's just a wonderful way not to have cords attached to you. So we want to help your wireless equipment work as best as it possibly can. So we invite you to visit our website, which if you signed up for the webinar, you probably have seen already, cnkengineering.com. And if you have any questions, you can email them to randy@cnkengineering.com. Visit our website. There's a send us an email link on there that you can click onto. And if any of you have any comments right now, we'll stay on for a few minutes. If you have any live chat comments you want to make or a question that we could possibly answer, we'd certainly be happy to stick around for a minute. So really thank all of you who took the time to tune into this, and I hope that we can be of some service to you. Well, Jaime, thank you so much, and I hope this was useful, and I hope we can, again, hear from you. And yes, Mark, and hope everybody learned something and found some useful tools. Okay, very good. Yeah, check with the boss. Okay. And like I said, feel free to send us emails with other questions. We can answer in plain non-technical terms if you wish, or we can reply with graduate level engineering terms if you wish. We have all the simulation tools. We have the test equipment and antennas to get an accurate picture of the RF environment in your venue, and we'd be more than happy to help you out with that. We have design services. We have computerized modeling that we prove out. Everything that we install and build comes with real test data, so you'll know what the performance of your equipment is. We do not sell wireless microphones, so we don't endorse any particular manufacturers over any other one. We hope that you buy the best quality equipment that you can, because you'll have the least number of problems with the best quality equipment that your budget can afford. The question is, will our new hearing loop be affected by the change? It depends on what type of hearing loop that you have. If you want to send us an email describing the model that you have and manufacture, we can certainly comment to you. There's several different kinds of hearing assist systems out there made by several different companies. Some of them are induction loop, some of them are infrared, which shouldn't be affected by the changes, and some of them are radio. Like I said, there's actually broadcast band ones, FM broadcast band ones, that allow people to use the FM chip in their cell phone or their iPods to receive them, and then the church doesn't have to provide the receivers to them. They just put in their earbuds and listen. And then there are other ones that have a dedicated receiver. So if you want to send us the model and we can offer you some information about whether that will be something that you'll need to change or if it'll affect the performance. If you haven't bought it yet, and there's something about it, maybe you want to get with whoever your vendor is or your installer and change it. But just send us the make and model, and we'll research that for you. Okay. I guess there's no other comments or questions. We'll bid you all good night, and thank you again for all joining in. And hope to hear from you soon.